Thank you for joining us. Today I'll be talking about our senior design team, the water channel team. So just to get started, our objectives. Our objective is to achieve a uniform flow within a certain test section in order to have experiments go on in that section. Our overview. Essentially, what will happen is we are going to drain the machine, we will fill it up again, and we will take measurements and create a velocity grid. That velocity grid will allow us to enter information into a CFD program, which will then be ran to show us where improvements can be made in the machine. The requirements and the verifications are that the channel must be drained and clean, as we did, and all algae and debris was removed. Flow testing was then done in the text section to create a grid. That information was used and inputted into a CFD program, such as star CCM. Star CCM was then ran in order to show us where improvements in the machine can be made. Once those improvements are analyzed, we will use SolidWorks to optimize the machine and increase the flow and to keep it consistent.
So for our maintenance, obviously shown in the left, you can see that the motor has been cleaned. There is still some rust remaining, however, this cannot be removed. And also the pipes have been stained just due to years of buildup. And you can also see the cavitation plate as well on there. In the middle picture, you can see our test apparatus, which is made with a 80-20 extruded aluminum. This just allows us to move horizontally and vertically throughout the test section to then gather our data. And this is along with a vernier flow sensor at the bottom. On the right, you can see our initial data, and this is for around 6 meters per second, or 0.6 meters per second. You can see that at the inner wall, it's actually faster than at the outer wall. And this will also change when we go up to higher speeds as centrifugal forces begin to build up. And we also modeled our main areas of concern in the Star CCM program, which includes our turning vanes, our motor, and also the PVC pipes, which will act as eddy current regulators, and then also the nozzle as well, which goes into the test section. Our plans moving forward are to combine the test data and the CFD simulations into a package where we can determine what improvements need to be made. Those improvements will then be made and the tests will be ran again, both in real life and also in the simulations. And the final data will be analyzed to see what our actual improvements have made. Here's our references and any of our contacts as well.